Okay, so take the range of f. Well, f of x is 3 plus 4e to the minus x. So this bit will go right down as x goes up further and further up. This one comes down closer and closer to 0, so it can't ever get down below 3. In fact, it can't ever get to 3 because this bit will always be a little bit positive. So therefore, the range of f is greater than 3, not greater than or equal to. Find an expression for the inverse of x. Okay, so inverse of x, I'm going to put the function f of x as y, and so you get this part 2. So you get y equals 3 plus 4e to the minus x, and then you rearrange that until you get x equals. So first thing I'm going to do is switch it around to the other side because I prefer doing it that way. 4e to the minus x plus 3 equals y, and then keep on undoing things. Take away the 3, so 4e to the minus x equals y minus 3. Now divide by 4, so e to the minus x equals y minus 3 over 4. Get rid of the word of e, so that means I'm going to have to ln it, because that will be the inverse operation of that, so that will leave me with minus x equals ln of y minus 3 over 4. And now I've got to times by minus 1, so that means that x equals minus ln of y minus 3 over 4. And then that minus sign can go up in terms of power, so let's bring it up to here. So that will give me x equals ln of y minus 3 over 4 to the power 1. That is the index power going up to top there, and that means reciprocal. So I get x equals ln of 4 over y minus 3, and that means I now know that that's what it is, and therefore the inverse of x, but the inverse of x doesn't want the letter y in it because I introduced the letter y to make my life easier, and so the inverse of x must be a function of x, so I replace the y with x. So the inverse is ln of 4 over x minus 3. And that does that bit. State the domain. Well, you can't do ln of a negative, and so therefore, or indeed, I can't divide by 0. So the domain of the inverse is x has got to be greater than 3. And the range, well, when you do ln of something, you can get a negative number, you get a positive number, so the range is all real numbers. All real numbers. And that's question part 2 done. And now I need to do part 3. I'll do it up here. The equation y equals x meets the curve y equals f of x. So that is y equals 3 plus 4e to the minus x at the point P. So using an iterative process, using an iterative process based on the equation that x equals this. So I've got x equals 3 plus 4e to the minus x. Find the coordinates of P. Okay, so we've got y equals x. And so we start here, and it says starting value of 3. So x naught equals 3. So on my calculator, I'll put 3 and then press the enter button or the XE button. And that puts that in as my answer. And then I'm going to do, I need to put in 3 plus 4 times e to the power of negative answer. And that means every time I press the equals button, the first time it's going to give me, x1 equals 3.199148. And when I press it again, the answer, instead of the answer being 3, the answer is now going to be this. And that gives me x2 equals 3.163187. x3 equals 3.169162. x4 equals 3.168155. x5 equals 3.168324. and show all the things and give it correct to 3 decimal places. Well, now it's 168, 168. It's not changing. I keep on going. So x equals 3.168, and we know that y equals x because it said that's what I have to do. So y equals x. So y equals 3.1682, and so the point P is 3.168. 3.168. And finally, I got to the last bit. I do it in red because it's getting a little bit cluttered. So the final bit: how is the point P related to the curves y equals f of x and y equals f minus 1 of x? And this bit, point P here, well, since this bit, both of the inverse of a function is just its reflection in the line y equals x, we've worked out that when y equals x and y equals f of x, so since the P is where they intersect, so P is where these intersect, and because inverse is a reflection in y equals x, and that's that. And that's question 7 done.